Hi everyone, this is Aaron. This is video 3 of a tutorial on TI-Nspire CAS calculator. In this video, I'll talk about the basic settings and navigation tips of the graphs page, how to use different graphs entries, as well as how to find points of interest. Let's get started. First of all, I'll talk about the basic settings and navigation tips. You can access the settings in menu 9, and you only need to change two things. First of all, you need to pick a large float number so that you can see more decimal places and improve the accuracy. Secondly, you need to change this graphing angle to radians because that is the one that's most commonly used. And then hit OK to save it. Now let's try to graph something. For example, we can graph x minus 6 squared and hit enter to graph it. As you can see, currently this graph is only occupying a quarter of the screen. And if we want to make it fill the screen, we can do menu 4A, which is zoom fit, and here it fills the screen. But then now we have another problem. We're seeing a lot of the left side of the graph, but not enough of the right side. And if we want to change that, it's also really easy. We can do menu 4.1, which is window settings, and here we can adjust the domain or the range. Currently, we only need to change the domain, so maybe change the upper bound to 20, and now we can see most of the graph. Also, since we have this menu 4A, which is a really convenient feature, I would recommend that most of the time you just change the domain first and then use menu 4A to adjust the Y values. Pretty easy, isn't it? Next, I'll talk about graph entries. You can access them all in menu 3, and you've got 8 options. But in terms of methods and specs, most of the time you're going to be using function or relation, and sometimes you may use parametric or differential equations to sketch the slope field. I think they aren't too hard to learn, so I'll just give 1 or 2 examples for each. Let's go to relation first. If you want to graph a relation, you just need to type an equation using x and y. For example, if you want an ellipse, you can do, you can just do this. And here's your ellipse. Another really useful feature of relation is that you can use it to graph inverses. So say we have already defined a function, x cubed, right? And we want to graph its inverse. It's really easy to do that using relation. Another way to get to relation is to hit delete and do 6. So if we want to graph the relation of fx, we can just type x equals fy. Oh wait, it should be x equals f1y. Yep. And here's its inverse. Yep. Now let's move on to parametric equations. So you would just define a function for the x and y coordinate respectively. For example, if we want the unit circle, we can just type x equals cos t and y equals sin t. This is the domain, and sometimes you may need to adjust that depending on the question. And this is the step size. You don't need to change that. Yep, and here's the parametric equation. Right, now I'll talk about the slope field. Since this is pretty clustered already, I'll go to a new page. Right, and you can access differential equation through menu 3x. And so here is where you type the derivative. However, say the derivative is x over y. If you just type x over y, nothing happens. It doesn't work. Why? Notice how we've got a y2 here and a y here, right? So basically, if we want to say y, we can't just type y. We need to type y2 so that these two things match. And now if we hit enter, everything would work. You can also specify initial conditions to graph a specific solution. For example, you may do like when x equals 0, y equals 1, and here's the solution. Also, I would recommend that if you need to graph multiple slope fields, you wouldn't go to y3. Instead you would just change the definition of y2. Why? Because once you have defined y2, right, it would restrict the choice of y3, as it would force you to give an initial condition, and it would fix the x value of the initial condition, which is pretty bad. So yeah, what I would do is I would just go back and change this definition instead of defining a new one. That's it. Finally, I'll talk about how to find points of interest on a graph, and we'll use this one for practice. So sometimes maybe you're given the x-coordinate and you want to find the corresponding y-coordinate of a point, and you can do that through graph trace, which is menu 5.1. So say you want to find what is the value of y when x equals 0.9. One way of doing that is to just keep hitting the right arrow key until you get to the point, which is negative 0.171. But a faster way of doing this, if you know the x-coordinate, is to just type the x-coordinate and hit enter, and it will instantly take you to the point that you want. Now, other times, maybe you want to find a more special point, for example, a local maximum or an x-intercept, and you can do that through menu 6. Now, 0 just means x-intercept, and these things just refer to absolute minimum or maximum instead of local ones, so sometimes you need to be more careful. And for option 1 to 8, excluding option 6, once you selected it, it will ask for a lower bound and an upper bound. So for example, if we select 0, it will ask for a lower bound and then an upper bound. It would be really tedious, especially on the handheld, if you have to actually move your cursor to set the two bounds. However, a faster way of doing this is to just type in your bounds. For example, if I want the bound to be between -1 and 1, I can just type -1, and it would set the lower bound to -1, and type 1, and it will set the upper bound to 1. Now notice that the cast only find one x-intercept, and that is just the nature of the cast. So if you want to find multiple zeros, a wiser choice would be to do that in the calculator page instead of the graphs page. And for menu 6.6, you only need to enter one value, which is the x-coordinate, and it will tell you the gradient at that point. For example, the gradient is 74 when x equals 5. Now, one last thing that I want to mention is that menu 6.9 allows you to analyze conics, and I find that menu 6.9.6, the asymptote option, is especially useful. That is, when you're graphing a hyperbola, it is really useful to know its asymptotes. So for example, we've got a complicated hyperbola here, right? Yeah. And currently we only know the equation, and we don't really know what are the asymptotes. However, our cast can make it really easy for us. If we just do menu 6.9.6 and then click this, it will actually tell you what the two asymptotes are. So it'll be really convenient. Yeah, and that's it for today. If you enjoyed the video, please like or subscribe. I'd really appreciate it. Then see you next time.